Hi guys, this is Ariel Braunstein, and my video is on solving systems of equations with cubic functions. So, I'm going to walk you through two problems that should help. So the first problem is we're going to solve for x and y, where 4xy equals 9, and 4x cubed plus 4y cubed equals 27. So, we first learned how to solve systems of equations back in Algebra 1. So there were three ways we could do it. The first one was with graphing them. You could graph the two functions and see where they intersected, which would work, except this is a non-calculator question, and these are a mess to graph by hand. So then we also had elimination, which turns into a mess when you have to start cubing functions like this. So I'm not interested, which leaves us with substitution. So in order to do that, you have to set one of these functions equal to a variable so then you can plug it into the other one. So in this case, I'm going to set this equation, so y equals 9 over 4x. It's much easier eventually to write these as 3 squared over 2 squared x because you're going to have to cube them later on, and this is easier to deal with. So then I'm going to plug anywhere I see a y in this equation, I'm going to plug in this value, which leads, so after some simplification, you get that 4x cubed plus 3 to the 6th over 2 to the 4th x cubed minus 27 equals 0. So then you can multiply everything through by an x cubed, so you get this x cubed out of the denominator, and you're left with 4x to the 6th plus 3 to the 6th over 2 to the 4th minus 27x cubed equals 0. So then I'm going to set x cubed equal to u, so it's easier for me to factor. So then I'm left with 4u squared minus 27u plus 3 to the 6th over 2 to the 4th equals 0. There's not an obvious way to factor this, so I'm going to go back to the good old quadratic formula to factor it. So when you plug everything into the formula, the entire square root ends up equaling 0. It's really nice. Which leaves you with 3 cubed over 8. So we know that u equals 3 cubed over 8, which I'm going to write as 3 cubed over 2 cubed, and that equals x cubed. So then if you take the cube root of it, you get that x equals 3 halves. So then you still have to solve for y. So in order to solve for y, you're going to plug in the value of x you got, which is 3 halves, into this one of the equations. You can pick either one, pick the one that's easier. So in that case, it's the one without the cubes. So then you get that y also equals 3 halves. So then you get that y equals 3 halves and x equals 3 halves. You can check that by plugging them both into the equations and seeing if they equal the right value. And in this case, they do. So you're good to go. Now, unfortunately, some of the systems of equations aren't as simple. For example, this one, where xy divided by x plus y equals negative 2, and x cubed plus y cubed equals the 3 halves, or 32. If you try and do substitution, it doesn't work very well because you can't separate these two variables. So you can't substitute in. So then you have to look for another way. So one way you can do it is to look at the structure of this equation here. So if you notice, it looks very similar to x plus y cubed. So you get that x cubed equals 3x squared y plus 3xy squared plus y cubed. So then I rewrote it into a way that looks a little more familiar. So you get that x cubed plus y cubed equals 3xy times x plus y. So then if you notice, you have an x cubed plus a y cubed, and up here we have established that that equals 32, so you can plug in 32. Then we also know that if you rearrange this function, or this equation here, you get that xy equals negative 2x plus y. So I plug that into this, and with a little simplification, you get that x plus y cubed equals 32 minus 6 times the quantity of x plus y squared. So then I set x plus y equal to u because this can actually be factored, and I find it easier to factor it with just one variable. So we get u cubed plus 6u squared minus 32 equals 0. So then you got to go back to that rational roots theorem where you get that one of the roots could be either plus or minus 1, 2, 4, 8, 16, or 32. So you can do synthetic division on all of these until you find one that works. I'm not going to show you that. That's for another video or another time. So, but one of them that works is u minus 2. So then when you factor it out, you get u squared plus 8u plus 16 equals 0. So that can be actually factored again, so that you get u equals 2 and u equals negative 4. So up here we said that u equals x plus y. So we get x plus y equals 2 and x plus y equals negative 4. Unfortunately, that only helps us a little bit. So then we go back up to our original functions. And we find, so then you have to plug them in to solve for the variables. So then we'll start with x plus y equals negative 4. So we have xy over negative 4, because we established that this equals negative 4, equals negative 2. So then you get that xy equals 8, and then you have to do substitution again. So, y equals 8 over x. Then you plug it back into one of your original functions, and you do some simplification. Then I plugged in the u for x cubed again, and you get that u squared plus 2 to the 9th minus 32u equals 0. And you're back to the quadratic formula. It always comes back. So, when you plug it in, you actually get that the inside of the square root is a negative number. So you have some irrational numbers, or sorry, imaginary numbers. And those don't apply really, so then you go back to the other condition you established. You also got that x plus y equals 2. So in this case, now I'm going to try with 2 and see if it works. So we get xy over 2 equals negative 2. So then with some simplification, you can get that y equals negative 4 to the x. And then you're going to plug this negative 4 to the x into the original function anytime you see a y. So we have x cubed plus negative 4 over x cubed equals 32. And then the simplification begins. So you get that x to the 6th minus 2 to the 6th equals 2 to the 5th x cubed. And that equals 0. So u, and then again I'm going to substitute in u, so u equals x cubed. And you get that u squared minus 2 to the 6th minus 2 to the 5th u equals 0. And we're back to the quadratic formula one more time. So you plug it all in, and you get, you get that u equals 16 plus or minus 8 root 5. And that equals x cubed. So then you have to solve for x. So x equals the cube root of 16 plus 8 root 5, or it equals the cube root of 16 minus 8 root 5. So then, once again, you have to solve for y. So you can plug them back, both values of x, back into the original, one of the original equations, and you get y equals the other value of x. So you have two separate potential solutions. Thank you for listening, and I hope that helps.